Hello, student. We are starting our new topic, unit number 4 in grade 10, Newton's law of motion. All right. So, this unit is all about, it is speaking about forces, Newton's first law, second law, third law, and also they are in later part of this unit, they are talking about momentum as well as mass and weight. Okay, after this theory lesson, we are going to do a question practice sessions too. All right, we'll start the lesson. Okay, first of all, before studying about who is Newton and what he says as the laws, Newton's first law, second law, third law, everything, you must understand what is mean by this force. Force. Actually, these words are a little bit familiar. This word is a little bit familiar for us, but we still don't know an exact idea about force. All right. Now think there is a table. Okay. On the table, you're having a metal box. This box is at rest actually. Am I right? What is mean by rest? In unit 2, we are discussing about this. At rest means what's the idea? The object is not moving. Object don't have any velocity, any acceleration. That means the object is rest. What what am I want you to do? I want you to move this object, move this metal box. However, how you can do that? Obviously, you want to give a push by your hand in order to move this object like this. Am I right? All right. So now the question is, you are providing a current. You are pushing this box. Okay, but exactly what's happening? Exactly what is happening that you are providing a force. By pushing this object, you are indirectly providing a force. Am I clear? Yes. And also, I'm tying a rope here. A second situation. I'm tying a rope here and you are pulling this object this side. Can you understand? You are tying a rope to this metal box and you are pulling this object to this side. So what's happening now? Now also through the string, okay, through the string, you are providing a force in order to pull this object. All right. Now I'm telling, come here. Please hold this box in your hand. If you hold this box in your hand, what you're doing? Okay, what you're doing? If you hold this box in your hand, you are still providing a force. Can you understand? So, likewise, forces are in many places, many different forms. Okay, forces, we can't only say it's one form. We're having many types of forms of forces, everything. We'll study one by one. So, at the bottom line, you want to understand when you are doing pushing, pulling, lifting, compressing. Compressing means you are taking a sponge or something. You are taking a sponge. Okay, you want to make this as a thin sponge. You want to compress it. What you want to do? You want to give force this side also, this side also. In your hand, if you push like this, it will be compressed like this. Am I right? So in compression also, you are providing forces. Okay, forces are everywhere. If you are okay with the idea of forces, we can move to next thing. Okay, we'll continue the story with this metal box and table. Now think, all right, you are providing a force like this. Okay, like this. We are abbreviating force as F. I hope you know that. All right. So are you thinking whatever the force you are giving, whatever the force you are giving, this box going to move? Are you thinking like that? Think this as a heavy metal box. Metal, it's made up of metal, iron or something. You are pushing this box using your one finger. You are pushing this box using your one finger. I'm asking, is this possible to move this box using your one finger, only one finger push? this heavy metal box is moving. Can it happen? No. Until you are a world's strongest person, it's most likely to not happen. Okay, why? Because you are providing a force by your finger. Fine, fine. But understand that that force is not enough. That force is not enough to move this box. If I say the force is not enough to move the box, there should be a reason. You want to ask why? Why I am providing a kind of force now? So you taught me if we provide a force, box will move. So now I am providing a force by my finger, even though one finger it force is force. Why it's problem? The problem is even though you are providing a force to the right side direction, there is a opposite force by the object to the left side direction. Okay, to the left side direction, there is a opposite force. Opposite force means that is resistive force, which means it will resist. It won't allow. It will resist the force you are giving. If you able to overcome that resistance, if you able to fight with the resistance, and if you can cancel that resistance, then only the box start to move. I'm clear, I think. That resistive force we are calling as frictional force. Am I clear? Frictional force. All right. So if you by your force F, if you able to, however, if you manage to overcome this resistive force first, then only this object will start to move. Okay, so I understood the when I am giving force, there is a resistive force. Okay. So always are these a resistive force? Always we are getting resistive force, or else if there is any situation. If we keep metal box in table only resistive force. Is there anything like that? No. Always we are getting resistive force. If two surfaces are in contact with them, okay, if two surfaces here, table surface and this box, bottom surface, are contact with each other. So there will be a friction force. You want to overcome that force first, then only you can move or do whatever you want. I think I'm clear. Right. Next thing, we know that F means force everything okay, but there is another little clear concept behind this F. We'll see. Okay, think you are applying a sufficient large force. Okay, you are applying a sufficient large force. Why you are applying sufficient large force? What's our first concern? I explained this one. What our first concern? Our first concern is to overcome. Okay, overcome but to the resistive force, which is a friction force. Am I right? So, when in the moment when you are giving a large force, sufficient large force, this resistive force will hold on. In some point, it can't uh, able to balance your force. Can you understand? This resistive force, F force, friction force, cannot it balance the force. Okay, cannot balance the force you are providing. So we are calling that kind of force as unbalanced force. Am I clear? I'm telling that this the sufficient large force, okay, cannot be cannot be balanced by this resistant force. Resistant force is friction force, you know that. So if it's so, in that moment, this force is known as unbalanced force. So always in every situation, we are talking about unbalanced force. But you are providing a force and an object is moving. What's the force? Unbalanced force. Don't think twice. Yeah. So that's the story behind unbalanced force. So most of the students are still they don't know what is unbalanced force. So now understand it clearly. So the friction force is sound quite interesting, right? So when you are providing a force, it is providing a opposite force. Quite interesting. But we are not talking about friction force that much in this lesson. We are talking, but as a a separate lesson in your grade 10 syllabus. Okay. When that At that time we'll discuss about friction force. Okay. Now you okay with what is force and all. Okay. Force and all, you're okay with that. Now tell me, you are providing a force like this. Okay. Person A is providing a force like this. Okay. So you know that, okay, we'll leave the idea of this resistant force. Okay, he is providing a large enough force to move the force. So I'm pretty uncomfortable to say that much of long sentence, no? He is providing a large enough force to the until the unbalanced force is wouldn't balance and all. So I am naming that as unbalanced force already. So if I say unbalanced force, you want to get that idea. All right. Okay. So person A is providing a unbalanced force so that this object will move. Am I right? The object will move to this direction. Along the table, the object will move this direction. Okay. Now, what you are doing, you are going there and you are looking, one person is trying to pushing this metal object in the table. Okay, we'll help them. We'll help to you. Okay. You are going near to him and you are telling, I'll also help you. Okay. Now, what you are doing, you are providing another force by your hand. Okay. You are additionally, you also pushing this side. Okay. I'll mark you as a B. Okay, so person A also providing unbalanced force, B also providing unbalanced force. Can you understand? So what happened? What happened? This object will start to move faster. Can you understand? Due to the force, due to the additional force, this is additional force now. Already by the force of A, object is moving to the right side. Fine. You are coming additionally and giving a force. Now objects start to move little faster than that. Am I clear? Yes. In a second instant, what's happening? A person is, as before, a person is trying to pushing the force, pushing this object. You are seeing him, he is doing something, and you want to, however, he is your enemy, okay? You are not okay that he is pushing the object, you are not okay. Now, what you are doing, you are coming to opposite direction, this direction. Now you are giving the force this side. What will happen? What will happen? This is B, this is you. What will happen? Even though he is pushing, object is moving this side with a certain force, okay, certain speed, okay. Due to the push you given by opposite side, this object will slow down. Maybe it will stop moving. Maybe it start moving this direction too. Think practically. The object is moving this side, right side. You are providing force oppositely. Object can slow down. Object can stop. Object can change its direction of moving. Am I right? So what you can understand, if force is changing here, no, 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 no. If force direction is changing here, am I clear? If force direction is changing here, what's happening? The object will move opposite when you are providing a opposite side force. Okay, so according to this conclusion, according to this explanation, you can come to a conclusion. What is that? You know that obviously force going to have a kind of magnitude. Obviously no. So 10 Newton, we are the unit of force is Newton. Okay, unit of force is Newton. 10 Newton or 5 Newton or whatever the Newton, we having a certain magnitude. But does the direction matters here? Obviously, yes. Am I right? When you are giving force one direction, it's behaving differently. When you are giving the force to the opposite direction, the same object behaving differently. So what you can understand, the forces depends on magnitude and also very importantly, direction. So if a physical quantity is depends on magnitude and direction, what is that? It is a vector quantity. So understand very clearly, force is a vector quantity. Force is a vector quantity. It is depends on magnitude as well as direction. That's the conclusion. Good. Now they'll move to next thing. Okay, you know that force is applied on a point, which means you are applying a force like this. Am I right? You are applying a force like this. So actually, exactly where this force is applied. Where this force is applied. Exactly this point. Am I right? Exactly this point. Am I right? Exactly this point this force is applied. So what you can conclude, if you want to know in which point the force is exactly applied, and if you can draw a straight line along that applied force. Am I clear? You are drawing a straight line. Okay, dot dot line or whatever the line, you are drawing a straight line. I think I'm clear. I'm applying force here in the point of applying force. Here, this is the point where force is applied. From the point along this force, I'm drawing a line. Am I clear? It's an infinite line. You can't say this is this long, that long 5 centimeter. No, it's infinite line. If you do that, you are getting a line. That line is known as what? Line line of action. Line of action. Can you understand? Can you understand? So if force is like this, we'll say the force is like this way. So where is your line of action? The line of action should go like this. Can you understand? So why we need line of action and all? After we are studying this lesson, we are moving to next lessons. And those lessons, line of action is very important concept. Okay, we need line of action. For the time being, understand how to find or how to obtain line of action in this manner only. All right. So up to this, we are uh, winding up with the introduction of forces. Now we want to meet Mr. Newton, who is doing something under the apple tree. All right. So actually, who is Newton first of all? Newton is a very famous scientist. I think you guys know that. He is the one invented gravity. Okay, not invented gravity. He found there is a gravity. Like that, he is the one who first introduced or found the gravity. Did you understand? So if somebody asks, is that Newton? If I say Newton, you will get that apple story and all. Under the tree he is sitting, apple is falling on his head. That story. But Newton is not only related with gravity stuffs. He has introduced numerous things. Am I clear? He has introduced many things in science and especially physics. Can you understand? So out of them, he gave three laws. First law, second law, third law of Newton. Okay, we want to see what are the laws one by one, and we want to understand some laws containing equations too. We want to understand the equation, and especially, we want to know beautifully how these equations are, how these laws are applied in your day-to-day life. This one is very, very interesting one. Can you understand? We'll study Newton's first law first. Students, now listen, think practically. Okay, no need these textbook stuffs. Think practically. There is a box. Again, box and table, metal box and table. You are placed in a table. You are just standing beside it. Okay, this is you. You are standing and you are just looking the box. Now you want to move this box. Is the box will move? No. If you are just looking, you are not doing anything, nobody is doing anything to the box, but this box too, it will remain at rest. I already said rest means what? It's staying in same position without moving or without having velocity. No, that's a rest. So this box will continue to be in rest. Am I clear? If if somebody is not doing anything externally, the object in rest will stay rest. Stay rest. Okay. Now come to this diagram. This. Photo. Your friend is playing a baseball and he is hitting a ball towards you. This is you. This is you. The ball is coming fast toward you. Okay, you are seeing the ball. Yeah, you are seeing a ball is coming and coming and coming. So can you stop the ball? You are not doing nothing. Okay, your hands are not up. Okay, you can't do anything. The ball is coming towards you. Can you do anything to the ball? No. The ball will continuously it will come and hit you. That's all. So from this example, what you can understand, if a object is moving, if a object is moving, when it is moving, if anyone is not doing anything externally, if there is no external problems or external forces or anything, the object will continue to move. It won't stop, continue to move. Okay, so by when you are standing in front of the ball, if the ball is hitting you, what you are doing? You are the external force. You are blocking the ball, then only ball will move to any other direction. It will slow down, it will stop, it will fall down. Other than that, ball will continuously come in. So if there is a no forces or something externally, the object moving is will continue to move. If we put together these two idea, we can obtain what Newton say as Newton's first law. We'll see that law. We'll read that law first of all. Read. Until an unbalanced force is applied on it. Okay, until an unbalanced force is applied on it, bodies at rest remain stationary. Stationary means not moving. And bodies in motion continue to move. Stop here. Okay, so you can understand what is unbalanced force. I explained already. If there is a no external unbalanced force is applied on an object, the object, if this object is remains rest, it will stay stationary. If body is in motion, which means if the body is in moving, body means object. If the object is in motion, it will continue to move if there is a no unbalanced force apply on it until only. If there is an unbalanced force, they will behave differently. Until unbalanced force means if there is a no unbalanced force, this will behave differently. Sorry, this will behave in same manner. If it is a rest, remain rest. If it is a moving, it will move continuously. But understand when it is moving, there is some concept we learned in Unit 2, which is a uniform velocity. What is a uniform velocity? They are in 1 second, 2 second. If we start from 0, 0, 1, 2, 3, 4, like in each and every second, if they are having same velocity, we'll say 3 ms minus 1, 3 ms minus 1, 3 ms minus 1. Likewise, same velocity. We discussed this in second unit lesson beautifully. Okay. Same velocity, we are calling that as uniform velocity. All right, good. So, if there is a no unbalanced force means is the object can accelerate, which means it can increase its velocity? No. It can decrease the velocity. Can it decelerate? No. Practical thing. So it will continue to move uniform velocity. So that's what Newton is saying. Now you can read fully. Okay, that's what Newton is saying. That's why they are telling us uniform velocity. Can you understand? Okay. Now the question comes. If you are a genius student, if you are a good student, great student, you will ask the question. Okay, sir, you are telling. So leave this story, come to this story. Yeah, I have the doubt. Okay, sir, this ball is coming. Take this example, and this ball is coming. Even though this ball is coming towards me in a uniform velocity, same velocity, constant velocity, all the same, uniform velocity, you are saying this ball will can't change its speed. It won't increase its speed, it won't decrease its speed. Likewise, only you are saying no. But practically, what's happening? If you throw a ball, this ball is continuously moving. No, it will move. But in some point, it will reduce its speed, and finally, it will, in some distance, it will drop into the floor. Why? So Newton is saying, not I am, not me. Newton is the one, I don't responsible for this. Newton is the one saying it will move in uniform velocity, but real situation is different. Object is moving, but it will fall down, it will reduce its speed and fall down one time. There is a reason. Newton also correct, happening this also correct. How? In order to understand that one, we'll take a carom board and we'll understand. Now, we are using this carom board. You are using the disc. You are going to strike this coin. What's happening if you are striking a coin? This disc is moving actually. Moving. When it moving, you can understand if it is a brand new carom board, what will happen? It will move somewhere and it will stop. See, it will move like this and it will stop here. Am I right? If it is a brand new carom board. So for that, players and all who are playing the carom board, what they will do? They will use something called talcum powder, a kind of powder. In Sri Lanka, it's baby powder, but actually it's a talcum powder should be used. What's happening in the talcum powder? If you put talcum powder, the disc which is stopping here will move continuously like here. For an example, it should stop here. Because of talcum powder, it moving somewhere. Sometimes it will come again also. That kind of smoother, it will move faster, smoothly. Why? You are striking same force. This also a kind of force, I think you know that. This also you are providing same force. But why this disc is behaving with the talcum powder, without talcum powder differently? Why? Because talcum powder is reducing the friction, resistive force. Am I clear? See, if this is a disc, okay? What's happening? When you are providing a force this side, this will provide a opposite force, resistive force. I explained now. Am I right? Oppositely. So where this opposite force is coming? This opposite force is coming from the surface which is contacted by the board surface, the carom board surface, and the bottom part of disc. From there only resistive force is coming. If you put talcum powder and if you make this carom board surface smoother, okay, not rigid, it's smoother, then what will happen? Due to the smooth surface, this disc will move smoothly. Why? Because the resistance force is reduced. Can you understand? So, however, if you manage, however, do something new things, and you are managed to stop this resistance force 100%. There is 100% purely no resistant force. It's impossible, but let's say, imagine you done that, however, what will happen? This disk won't stop anywhere. This disk will move continuously, it will move, it will move, it will move. You can't have these barriers and all. If you use this disk and a flat surface and you reduce the resistance 100%, then this disk will move continuously to the lifetime. It's not possible, but it can move. So what you can understand, even though this disk can move continuously using the same velocity, due to the resistant force, due to the friction force, this disk will stop somewhere in the board in real situation. So at likewise same situation here too. What's happening? Here also this ball is coming, but in movies and all you can see that one. If even though the ball is coming like this, the air will the ball is coming this side means the air will hit the ball like this side opposite direction. Am I right? Yeah, and that dust particle in the air, everything will hit the object. Hit the object. Because of the heating, you can say that's yeah, no, the wind. Okay, does it have that much of mass to stop the ball and all? Yes, it have. Yes, it have. You will feel lightweighted, but it's have that potential. So due to this one, this is actually acting as resistant force here. Resistive force here, this is acting like that. Can you understand? So due to this resistant force only, the uniform velocity motion is get problem. and it will slow down, slow down, slow down, slow down, and one time it will become to rest on the floor. Can you understand? If you can't understand this concept, watch it again. Okay, dream, watch it again from Newton first law topic. Okay, next interesting concept in our Newton first law is this bus concept. Okay, so you having an experience this situation. Okay, you are standing in a bus. A person is standing in a bus without holding anything. Okay, without holding this bar or upper bar or whatever, is just standing on the middle of the bus. What's happening if the bus is going smoothly? Okay, bus is going smoothly. This person is standing in middle of the bus. Suddenly, if bus brakes, okay, if driver press the brake, he will throw a front like this. Like this photo, this person will throw frontwards. Why? Why? He is moving like this. What's the reason actually? You want to know the exact reason? Think this practical situation. When you are standing in a bus, okay, when you are, look, please understand this one. This will be questioned directly. When you are standing in a bus, okay, this bus is moving. Am I right? This bus is moving to this direction. When the bus is moving, any other parts of your body, your head, neck, hands, in your upper part of the body, no part is contacted with any part of the bus. Am I right? The one and only part which is contacted with the bus is your feet. Your feet only contacted with the bus, with the flow of the bus. So when the bus is moving like this, the feet and the bus having same velocity. Can you understand? This feet and bus having same velocity, as well as your upper part of the body also having the same velocity. So in this situation, you can ask, no, I'm feeling like I'm standing in a same position. So how you can say I'm having a velocity, even though you are feeling like that you are standing in a same manner relative to the earth. Okay, related to the earth, you are having a certain velocity, the velocity of bus. Then the bus brakes suddenly. Okay, when the bus brakes suddenly, what's happening? The velocity of bus became suddenly zero. Am I right? Velocity of bus became suddenly zero. Your leg is immediately contacted with the bus. See, your leg is immediately contacted with bus. So if bus flow is zero, ms minus one velocity, which means velocity drops to the zero quickly. Your leg also. Okay, the immediate contact surface, your foot, also becomes 0 ms minus 1, which means 0 velocity. The velocity drops suddenly. Am I clear? But your upper body, since it is not contacted with any part of the bus, since it is not contacted with any part of the bus, your upper body will continue to move. Can you understand? So here in this human diagram, see this leg part is zero. The leg part not moving, 0 ms1. Okay, your upper part is still moving. Why? This is not contacted with bus, no? Your upper body is still moving. So one part is moving like this, one part is moving like this direction. Upper part, this body is staying same. So this will fall like this direction, right? Can you understand? This leg position is same, which means 0 ms minus 1, the same as bus velocity. Your body is not ready to stop. Why? Because it's not contacted, no. So since it is moving, upper part is moving, this part is zero. That's why you are falling forward. Am I right? You are falling forward. That's the reason. The direction which bus is moving, that direction you will fall. Can you understand why? Again, one last time I'm telling, your leg will be become rest suddenly due to the braking of the bus. since it is contacted with bus flow, but your upper body is won't become rest because nobody is there to tell this bus is rest. No. Why? Because it's not contacted with any surface of the bus. At the same time, if you are standing same, okay, if you are standing in a stopped bus, the bus is stopped. Okay, you are standing like this and you are using mobile phone and you are not holding anything. In middle of the bus, you are just standing. What's happening now? Who is at rest? Who is at rest? Your total body is at rest. Am I right? Your total body is at rest. You also not moving, bus also not moving. Everything at rest. But if driver suddenly start the bus, suddenly moves the bus, what happened? Your upper part is rest, okay, but since your leg is contacted with the bus flow, this leg suddenly became the velocity of the bus flow. Can you understand? Your legs velocity and this bus sudden velocity will be equal quickly, which means it will move like this, but your upper part of the body will remain rest for a couple of seconds or minute. Couple of seconds we can say. So this is rest, this is moving. Your upper part is rest, 0 ms minus 1. Your legs are moving. What will happen? So your upper part will be staying 0 ms minus 1, while your leg part, the feet which contacted with bus flow will go to this direction. So you will slantedly go backwards like this photo. You will go backwards in which the direction of bus. Can you understand? These are the reasons. So you want to beautifully, you want to write that one. Okay. How to write the answer for these kind of question, it will given in the tute. You can refer that one. All right. We'll move to the next one. Last thing in Newton's law of first law of motion. See in this one, why everyone are saying you to wear a seat belt, wear a seat belt. That will say why same whatever we are studied. So don't think about lower part of the body. It is always remaining rest now. Think about upper part of body. Upper part of body is what's happening. If you are not wearing a seat belt, if you are not wearing a seat belt, you are not in contact with car. Am I right? So here also, if you give a sudden brake, this lower part will become rest. But your upper part don't know at rest or whatever, it will continue to move. Can you understand? Your whole body is moving. With the car, your whole body is moving, whole body having same velocity. But at one instant, your lower part of the body only becoming zero velocity. With the brake, zero velocity. But your upper part of the body will continue to move. That's why your head will be hit with the steering wheel and all. Accident, problem. But if you wear a seat belt, this seat belt is, if you brake, this seat belt will give the 0 ms minus 1, which means zero velocity for your body, upper part of the body. So that you won't move front and you won't have that much of serious injury, head injury. Everything will be prevented using seat belts. Okay, this also acting according to Newton's first law of motion. All right, so with this, we covered introduction of force and also we covered Newton's first law. So we'll wind up with this in second video. In next video, we want to study about Newton's second law of motion. Bye.